Determinant expansion. In this, we're gonna see three cases of the expansion of determinant. In the first case, we're gonna expand the determinant of matrix of order 1, that is 1 cross 1 matrix. And in the second case, we need to expand the determinant of matrix of order 2, that is 2 cross 2. And in third case, it is of order 3, that is 3 cross 3. So first one, determinant of matrix of order 1, that is 1 cross 1. If A is a matrix of order 1, then the determinant of A is defined to be equal to A. For example, if a matrix A is 3 of order 1 cross 1, there is one row and one column, then the determinant of this matrix, which is also represented like this, is equal to that of 3, that is equal to just 3. Okay. Now, the second case is determinant of matrix of order 2, that is 2 cross 2. If A is a matrix of order 2, then the determinant of A is represented like this. So, if this is a matrix of order 2 cross 2, that is 2 rows and 2 columns, then the det A is represented as, first do the cross multiplication of these two diagonal elements. These are called as the diagonal elements, that is A11, A22 minus then these two elements A12 and A21. So this is what I've written over here. Now let's see an example. Let a matrix A is 2, 4, minus 1 and 2. Then how to find this determinant? So that of A is represented like this, that is 2, 4, minus 1 and 2. Now first we need to do the cross multiplication, that is 2 into 2 minus the other two elements, minus 1 into 4. Just simplify this, 2 2s are 4, minus into minus plus, 4 1s are 4, that is 8. So 8 is the answer for this matrix. So let's see the third case. Before getting into the third case of order 3 cross 3, first let's see few terms which is called as a minor and a cofactor. What are they actually called? So minor is nothing but which is an element of matrix Aij and it is expressed as Mij and it is obtained by removing ith row and jth column. For example, if a matrix A of order 3 cross 3 is given, that is A11, A12, A13, A21, A22, A23, A31, A32, and A33. So this is a matrix of order 3 cross 3. Then if we need to find the minor of A23, we will represent it as M23, that is Mij, which is nothing but how to obtain it by removing the ith row and jth column. So I is 2 over here and j is 3. So by removing second column and third row, sorry, by removing second row and third column. Second row is this and third column is this. So after removing this, what are the elements which are left? We write in the form of det, that is determinant A11, A12, A31 and A32. So these are the elements left and minor is obtained by calculating its determinant. How to calculate its determinant? By doing the cross multiplication, right? That is A11, A32 minus A12, A31. So this is how we calculate the minor. So next thing is the cofactor. So cofactor of an element Aij is expressed as Cij, and it is calculated using this formula. It is basically, it is either similar to, so this Cij will depend on the Mij by either, there are two cases. Cij may be equal to Mij, Cij is equal to Mij, or Cij may be the negative of Mij. So when are these two cases are possible? So if Cij equal to Mij, this case is possible when I plus j is even. If it is an even number, so minus 1 whole power even will gives you a positive. So when I plus j is even, this case is possible, and when I plus j is odd, it becomes the negative of Mij. So similarly, let's take the same example of matrix A. Let's calculate the cofactor of A23. That is, it is represented as C23. So the formula is minus 1 whole power I plus j. What is I? 2. What is j? 3. So 2 plus 3. What is Mij? That is M23. So minus 1 whole power 5. M23 is nothing but this value. That is A11, A32 minus A12, A31. So it basically, minus 1 whole power 5 is a negative number. So it's just the negative of M23. So this is how we calculate the minor and cofactor. So let's take an example so that you'll get a clear idea on this. In this question, we need to find the minor, that is M31, and cofactor C23 in the following determinant. So M31, that is third row, first column, that is this element. So how to calculate this? M31, just remove the third row and first column. So what are the elements left? 2, 3, 1 and 2. Take this determinant, that is 2 into 2 minus 3 into 1. 4 minus 3, 1. So the value of M31 is 1. Next, how to calculate C23? It is minus 1 whole power I plus j. 2 plus 3 is 5, M23. So it's just the negative of M23. So what is M23 over here? First, let's remove this. So second row, third element. Second row, third column. So this is the M23, A23 element. Now we need to remove this corresponding column and corresponding row. So what are the elements left? 1, 2, 4, minus 1. Take its determinant. The negative is outside, okay? 1 into minus 1 is minus 1. Minus of 4 to the 8. So it is minus 9, which is plus 9. So C23 is 9 and M31 is 1. In this question, it is told that if the determinant value is equal to x plus iota into y, we need to find the values of x and y. So assume this is determinant of A. So this determinant of A can be written as A11, that is 6i into M11. So assume this is determinant of A. So determinant of A is calculated by A11 M11 minus A12 M12 plus A13 M13. So let's calculate first M11, M12 and M13. So M11 is eliminate the first row and first column. The leftover elements are 3 iota, minus 1, 3 and iota. So it's just the multiplication, that is 3 iota into iota is 3 iota square minus of minus 3. Iota square is nothing but, what is the value of iota? That is root of minus 1. Iota square will be minus 1. So 3 into minus 1, minus 3. This is plus 3, which gives you 0. Next, M1, 2. Just eliminate the first row and second column. This is 4. So the leftover elements are 4, minus 1, 20, and iota. So it is 4 iota, minus into minus plus 20. Next, M13, just eliminate the first row and the third column. So the leftover elements are 4, 3 iota, 20, and 3. So it is 4 3s are 12, minus 23s are 60 iota. So just substitute the values over here. That is A11 is 6 iota, M11 is 0, A12 is minus 3 iota, M12 is 4 iota plus 20, A13 is 1, so M13 is 12 minus 60 iota. So just simplify it. It becomes plus over here. So 4 3s are 12 iota square plus, no? So it becomes plus 60 iota plus 12 minus 60 iota. This and this gets cancelled. So here basically iota square is nothing but minus 1. So it becomes minus 12. So this minus 12 and plus 12 gets cancelled. Therefore, the value of this determinant is 0. So hence, the x and y values also become 0 in this question. In this question, we need to find the value of delta. So what is delta? Just the determinant of this whole thing. So in this question, we need to find the value of delta. Delta is nothing but the determinant of these elements. So how to do it? A11, that is 0, into the determinant, that is M11. M11 is nothing but eliminating its first row and the first column. The leftover elements are 0, sine beta, minus sine beta, and 0. Minus A12, that is sine alpha, and M12 is eliminate its first row and second column. The leftover elements are minus sine alpha, sine beta, cos alpha, and 0. Next, A13 plus minus cos alpha, eliminate its first row and third column. So the leftover elements are minus sine alpha, 0, cos alpha, and minus sine beta. So just calculate it now. 0 into something is always a 0. Minus sine alpha outside, and inside it becomes sine minus sine alpha into 0 is 0. Minus of cos alpha into sine beta. And here it is plus into minus minus cos alpha. Inside it becomes minus into minus plus sine alpha sine beta. And this becomes 0. So from here we can write it as sine alpha cos alpha sine beta minus sine alpha cos alpha sine beta. So the value of this is 0. Now let's see the third case, that is determinant of matrix of order 3, that is 3 cross 3 matrix. It is the sum of product of elements of a row or a column with their corresponding cofactors. This definition looks something complicated, so let's take an example. If a matrix A is given, that is A11, A12, A13, A21, A22, A23, A31, A32, and A33. This is the matrix of order 3 cross 3. Then we denote the determinant like this, that is sum of. So first take a row or a column. Choose any row or a column. Like let me choose this first row. Now first we need to do the sum of the elements of a row. Sum of the elements that is like this. And to these elements, we need to do the product of the corresponding cofactors. So what are the corresponding cofactor of A11? That is C11. For A12, it is C12. For A13, it is C13. So this is how we calculate the determinant of A. And if you write in terms of minors, this can be written as determinant of A is equal to A11. C11 is nothing but minus 1 whole power 1 plus 1 M11, which is nothing but minus 1 whole square, which is plus only, na? So it just remains plus of M11 plus A12. C12 is minus 1 whole power 1 plus 2, that is 3. So it becomes the negative of minor. So in place of C12, we can write the negative of M12. Whereas for C13, it is minus 1 whole power 4. Why 4? It is 1 plus 3. So it just remains as it is. So it is M13. So hence the final determinant will be A11 M11 minus A12 M12 plus A13 M13. So if we write in terms of minors, basically if this is the determinant, the first element will take positive, next negative, next positive. This is how we written this. See, it is plus of A11 M11, negative of A12 M12, next positive of A13 M13. Similarly for the second, it starts with minus again, plus, minus. It's just the alternative. Again plus, minus, plus. If you look at the row wise or the column wise, it is something like alternative. If you look at the column wise, it is also again alternative. So this is how we calculate the determinant of matrix of order 3. So let's see an example for this. In this question, we need to find the determinant of this matrix. Assume this is a matrix A. So we need to find the det of A. That is, let's assume this, consider this row. So it becomes A11, M11 minus A12, M12 plus A13, M13. So what is A11? It is the 1. How to calculate M11? By eliminating its corresponding row and column, right? So what's left? Det of 3, 0, 1, 0. Just do the cross multiplication. We're left over with 0. So into 0 minus what is A12? It is 2. So how to calculate M12? Eliminate its first row and second column. So when we do that, the leftover elements are minus 1, 0, 4, 0. Now this, when you calculate the determinant, the answer you'll get is 0. What is A13? It is 4. How to calculate M13? Eliminate its first row and third column. Actually, this element is 3. So what are the leftover elements? Minus 1, 3, 4, 1. Just calculate the determinant, that is minus 1 into 1, minus 1, minus 12. So that is minus 13. So it just becomes 13 fours are minus 52. So this is the answer for this question.